The next thing that we want to talk about in today's lecture is the Internet of Things. This is not particularly well covered in the textbook, and it's also a fairly new construct from a security standpoint that is going to be with us for quite some time. I want to highlight the IoT journal. This is an IEEE publication, which has a very young history. It's kind of recent as well. But they also have a definition of IoT that's very interesting. They define it as a self-configuring adaptive system consisting of networks, plural, of sensors and smart objects whose purpose is to interconnect all the things, including everyday objects, so that you can do programming with the world and environment around us. I think the IoT is very, very difficult to define, at least in a way that makes sense from a security standpoint. Everything about the IoT is a little bit confusing, and so the next few slides are going to be part of my own research that I've done to try and clarify things. The first and biggest problem with IoT is if you're thinking of things versus devices, it can get a little bit confusing. So the example that I give here is a license plate reader. There are two different ways that you can do tracking of just vehicular traffic in a smart city, or for the purposes of discussion here, we'll say there are two different ways that you can do tracking of vehicles in a smart city. One would be to implant an RFID chip, a radio frequency identifier chip, in license plates themselves. So the license plate is here, and the RFID chip is a little thing that gets added to the license plate. Then when the car is driving through an intersection that has an RFID reader, the reader can actually read, using radio frequency, the RFID chip on the license plate and know this car happened to be near this intersection at this particular time and send that information off to some cloud where it can be processed. The alternative approach is to just use the license plates we already have and then have some kind of a smart camera read the license plate, and when it reads the license plate, it can then interpret it and send that data off to the internet. Now, these are both IoT models in the sense that we're doing the sorts of things that this definition is describing. It's an adaptive configurable system that uses sensors and objects to interconnect all these different things. The main difference, though, is if you are thinking of the thing that we're tracking the car, right? Or the license plate in this particular case. That is the thing in the IoT in both of these pictures. However, if you are thinking about the technology involved, there's major differences because we have devices. An RFID chip is a device, the radio frequency reader is a device, and the camera is a device. But in this case, it's just a giant chunk of metal. There's no intelligence, no technology, no nothing in the license plate for this second scenario. And that makes the IoT much more difficult to regulate, much more difficult to think about in terms of a security context. Because the security picture for these two scenarios is very, very different. In the first case, you could have owners of cars ripping out the RFID chips or blocking the RFID chips using some kind of like a Faraday cage, and then all of a sudden they're invisible. In the second case, that's not quite the same. You could mar your license plate so that it can be read by the camera, but it's not quite as easy as it would be because the technology is much simpler. In the second case. So some of the other problems with this difference between a thing and a device is that they provide very different contexts for what we're interested in. So a device could be a thing, but it's not necessarily a thing. And these other elements of the IoT, the sensors, articulators, identifiers, they can operate on things in ways that require some sort of component or device or network on the back end for communication purposes. But they're not themselves the thing, right? They're still separate from the thing. They're an identifier of the thing, a sensor that collects data on the thing, or an articulator that changes the thing, but they are not the thing. And both of these are problematic in terms of security and just in terms of regulating IoT. So a few more like real world examples of why this differentiation between a thing and a device is so problematic. If you are thinking about a smart refrigerator or a smart furnace, there's a couple of different ways they might work, right? In both cases, you would probably have some kind of a sensor that is attempting to read something about their environment. In the refrigerator's case, the sensor here is reading an RFID chip that is embedded into a carton of milk. And then you can tell when the carton has been added to the refrigerator, when it has been removed from the refrigerator. And you can make the sensor a little bit smarter than that. It could be, instead of an RFID chip, it could be just a like weight plate somewhere in the shelving, so that you would tell how much weight has been added to the refrigerator and how much has been removed and that sort of thing. In this particular case, we're trying to track, though, whether or not the carton of milk is in the refrigerator or not. And in the other case, we have a thermometer, which is reading the temperature of the air around the furnace, and that is essentially the thing that we're trying to read. So the furnace is the thing, and it has the device embedded into it. In this case, the thing we're trying to track is the milk, and it has two different devices that are associated, this RFID identifier and also the sensor that reads the identifier. And in both cases, we're going to connect this information to some kind of larger internet component as a whole. So these are two very different ways to consider IoT from a security and privacy standpoint. Another way of thinking about it, just kind of going back to the smart refrigerator example, is that there are four possible configurations, right? Just plain old objects. In this case, there is no IoT. It's just plain old milk and a plain old refrigerator. A milk carton as the thing that we're trying to track, right? And the refrigerator as the only device, because we have a camera that's looking to see if it can find milk somewhere in the refrigerator. And then option C is both a milk carton as the thing and the device, right? So the milk carton is the thing we're trying to track, and there is a device embedded into it that allows for easy tracking, right? The refrigerator is a device because it has the sensor, and the milk carton has an RFID reader, making it a device as well. And then finally, we have a refrigerator that has multiple device components independent of any of the contents of the refrigerator. So this is sort of like a scenario. These two middle scenarios are scenarios where we're trying to track a thing separately with multiple different devices. And this is sort of, I think, the people would typically think of as like the traditional version of the IoT, because the thing is the device. The refrigerator is the thing that we're trying to track, essentially the temperature in the refrigerator and whether or not to turn on the cooling element in the refrigerator. And that's also the device that measures those sorts of concerns. Another important concern with IoT is the kinds of devices. I've sort of been loosely saying all of these are devices with relatively the same logical equivalence, and that's not true. An RFID chip is a very, very simple device that can basically only provide identification. Some sensors are much more powerful than others. A temperature sensor really can only provide you with the temperature, but a camera can provide you with quite a bit more, right? So a license plate camera might capture not only license plates, but in some cases the people in the cars, right? And that would be additional data that could be sensitive in some way. The next step up would be a smart device that is both reading data like a sensor would, but also articulating on the environment itself. So this is like a home door lock that can tell you the state of the home, state of the door. Is it open, closed? Is the lock engaged or not? But it can also articulate the lock so that if the door is unlocked, you can switch it to a locked position, or if it's locked, you can unlock it remotely. And that is a step up from just sensing data. You're now interacting with the environment. The step beyond that is an application-specific computer. This is sort of like a general purpose computer that is used for one application. So in this particular case, a mall kiosk that can take search queries or respond to concerns as to where to go in the mall, or a department store, or some other like amusement park type scenario. And then finally, just computers, right? And now we're all the way back to general purpose computers, where the IoT is sort of like not as interesting, but there are still security concerns, right? So we all have cell phones, which are basically general purpose computers. We all have computers like laptops that can be traveled from one place to another. Those are also just general purpose computers. So this is the 5 device categories. And as we have seen, this is really more of a spectrum. It starts with like super low level identification only devices, moving all the way up to extremely powerful servers and computers that can be moved and so forth. So either you can think of it in terms of the categories or in terms of the spectrum. I think they're both totally valid models, but the main thing that you want to take away from this is that each of these have different security trade-offs. And so if we're talking about the IoT and IoT security problems, the main question you have to ask is, okay, where on this spectrum are you considering? Because the trade-offs of just an RFID chip are very different from the trade-offs of a smart appliance, very different from a tablet or a netbook or a laptop. And all of these can sort of be thought of as things that travel or on the IoT. And you can give examples from each of those categories as well. Lots and lots of things that people think of as IoT stuff. Refrigerators are an example that I like going to because there's lots of different configurations. Smart home, smart health, those are also very important. Smart transportation is turning into more of a thing with all of these autonomous vehicle companies getting involved in the industry. Wearables, since Apple started with their watch and Google started with their glasses, have become much, much more widespread, and certainly would qualify as a thing in the Internet of Things. And probably lots of other stuff that I'm not listing here would be relevant from an IoT perspective. I'd also just highlight there are challenges other than security. Loss of privacy is certainly an important challenge, especially with health data. That's a very important concern that a lot of individuals have about their smartwatch data. There's also a potential for subversion. I think it's very easy to imagine scenarios where, as soon as everybody is being tracked, people are going to try and hide that tracking. This has already sort of happened with just those toll cameras that would capture people who are using a toll road, people wearing hats or masks or things so that the camera is not actually able to see who's driving the car. A very important concern for regulating these kinds of devices, especially in traditionally problematic areas. And lots of other concerns from a security standpoint with IoT stuff that are very, very difficult to deal with. I'll also just say, from my perspective, this is not going away. This is going to only become more and more problematic the more computing that we spread throughout society. So if you are interested in saying which of these emerging concerns is really going to continue, not just now, but 5, 10, 15, 20 years, possibly an entire career from now, I think both the BSIM and IoT security concerns are going to be very, very prominent throughout the rest of your careers.